Hello students, welcome to day 2 of our 21 days challenge. If you're not done your day 1 problems, please go back to the previous video, complete the day 1 challenge and then start this video. And those who are already doing it, well done. You are doing a great job, fantastic, keep doing it. And I'm getting questions from few of you asking that whether you can get help for solving those two problems in the challenge every day. The answer is yes, you can get it, but try your maximum to do it by yourself. If not, you can refer other resources also. The main purpose of this challenge is not to do it perfectly without any help. The purpose of this challenge is for you to learn the concept, understand it, and try your maximum to do it. And make math practice as your regular habit. Okay, with that being said, let's dive into the day 2 challenge, which is all about rational numbers. So, what are rational numbers? Let's begin that. So, the rational numbers are nothing but a set of numbers like your natural numbers, whole numbers, integers, and so on. So, you all know that natural numbers are the numbers which begins with 1. 1, 2, 3, and so on. And whole numbers are the ones which will begin with 0, 1, 2, so on. And integers are the one which will start with a negative value, goes on up to 0, and again goes on up to positive infinite. And coming to rational numbers are the numbers which can be written in the form of p by q. What p and q are? They are nothing but integers, meaning that the numerator and the denominator can take positive values, 0 and negative values, except that q cannot take 0, because if denominator is 0, then we can't find the answer becomes undefined. So the main condition for a rational number is it should be in the form of p by, it can be represented in the form of p by q, and the denominator cannot be equal to 0. So now you can ask me, ma'am, so 2, which is a natural number, is a rational number. Yes, of course, because 2 can be written as 2 by 1, p by q form. So whole numbers are also rational numbers. Yes, because it can also be written in the form of p by q. Integers, what about negative 5? Is it a rational number? Yes, of course, because it can be written as negative 1 by 1, which is a rational number. So it means all your natural numbers, all your whole numbers, all your integers are obviously a rational number. Now you can ask me, ma'am, what about decimals? Decimals are rational numbers. Say for example 1.5, 7.25, 0.05. Are these rational numbers? Let's check whether these numbers can be written in the form of p by q, in the form of numerator and in the form of fraction. Yes, of course, we can write this. 15 by 10, 725 by 100, 5 by 100, 5 by 100. So it can all be written in the form of p by q. So these are all rational numbers. So ma'am, what about this? 1.666 goes on, 1.727272 goes on. These numbers are rational numbers? Yes, of course, these are rational numbers, because there is a way on how you can write this number as p by q form. So these are all rational numbers. Now you can ask me, ma'am, what about this 1.73256778? It goes on, non-repeating only, but it is not repeating. Okay, not terminating only, but not repeating. There is no pattern like 7272 or 6666. Are they rational numbers? No. This alone cannot be a rational number. Okay, so finally, to summarize, what are rational numbers? Rational numbers are numbers which can be written in the form of p by q, whereas p and q are integers and q is not equal to 0. So it includes all your natural numbers, whole numbers, integers, plus the decimals which are terminating 1.5, 1.75, like that. Terminating decimals are all can be written in the form of p by q, so it is a rational number. And certain decimals which are not terminating but they are recurring. Recurring means repeating. Okay, recurring, or otherwise we can say it as repeating also. So these are the ones which can be called as rational numbers. Okay, I hope you're clear with the definition now. Now let's dive into the problem, but before that, let's see how we can represent. So all the natural numbers, whole numbers and integers are represented on the number line, right? You can ask me this anytime. So ma'am, if you ask me where is 4 on the number line, I would plot here. What is a number line? A line which has numbers on it. As simple as that. So 4 I can plot it. 0 I can plot it. -3 I can plot it. But how do I plot the rational numbers? Say for example, you have two integers 0, 1, 1. So how many rational numbers are between any two integers? Only one, 1 by 2. What is the half of 1 by 2? 1 by 4. Half of 1 by 2 and 1, 3 by 4. Half of 3 by 4 and 1. Half of 1 by 2 and 1, 3 by 4. Half of 1 by 4 and 1 by 2. Half of 1 by 4 and 0. So literally there are infinite number of rational numbers between 0 and 1. Okay? Similarly, you can also ask me, these two are integers. Now let's take two rational numbers. Say for example, 3 by 10 and 9 by 10. Okay. Here also there are 4 by 10, 5 by 10, 6 by 10, 7 by 10, 8 by 10 and so on. So what we can say from this, there are infinitely many rational numbers between any two integers or any two rational numbers. Easy? Very good. Now you can ask me, ma'am, this is easy. You can find it very easily. Now let's take two different numbers. Say for example, 1 by 4 and 3 by 2. Before I chose 3 by 4 and 3 by 10 and 9 by 10. Both these are like fractions, so I know all the numerators in between those. Now what about this? These two are not like fraction. Okay, so how do I get it? Simple, just get the equivalent fractions. So this, let us keep, since LCM is 4, keep it like this. So whereas this can be written as 1 by 4 and 6 by 4. So literally 2 by 4, 3 by 4, 4 by 4, 5 by 4. All these are between the two rational numbers. So you got 4 rational numbers between this. Suppose if they ask you 50 rational numbers, what will you do? Just multiply by 10 and make it as a bigger equivalent fraction. So 10, between 10 to 60, there are 50 rational numbers. Suppose if you want 100 rational numbers, just multiply by 100. You get 500 rational numbers between these two rational numbers. All get it? Getting it? Super. Now, one more thing which we missed in the before explanation. Suppose, ma'am, you told me how to convert the terminating to fraction form, p by q form. How do you convert this? 6666. How do you convert? Sorry, the bar is not needed as of now because it's repeating. Or it can be simply written as 1.6 bar. How do I represent this? That's a very good question. So let's take this as 1.6 as 6 bar as x. The main purpose is I need to make this digit, recurring digit, repeating digit after the decimal. I have to bring this recurring digit just after the decimal point and I have to cancel out, eliminate that recurring. So what I'll do, I'll get one more number from this, making it as 10x. Multiplying by 10, I get 10x, so I get 16.6 bar. So if I subtract these two now, 10x minus x, 16.6 bar minus 1.6 bar. So all my recurring sixes will get removed. So simply you will get 9x equals to 15. So x equal to 15 by 9, which is 5 by 3, which will give you 1.6666 as the repeating one. So this is how I convert the recurring non-terminating decimal into a p by q form. So now comes the question for you. What is that? Yes, let's start. So this is the simple problem for you to just practice. Okay, you have to find as much as rational numbers possible between 1 by 2 and 1 by 5, 3 by 4 and 4 by 10. Sorry, 3 by 10 and 4 by 10. Okay, just for you to practice. The next one, which is this one. How do I convert the recurring one? Okay, this is terminating one. You all know that. Recurring. So 0.13 bar. So 1 is not non-recurring, 3 alone recurring. So I'll take x. I cannot work with x because 1 non-recurring is there. So I'll make it as 10x and make the recurring alone go after the decimal. So 10x is 1.3 bar and 100x is 13.3 bar. Right? Now I'll subtract these two. I get 99x equals to 12. So x equal to 12 by 99, which is 4 by 33. All the steps can be simplified into a simple formula, which is this. I want you all to note down this in your notebook. Okay. So the recurring decimal will be equal to a minus b equals to 10 to the power of c minus 10 to the power of d. What is that? Say for example, if the number is 1.231 and goes on. So it can be written as 1.231 the whole bar. Since the recurring alone is there after the decimal, I'll take this as directly x. Okay. So using this formula, I can find the number easily. How? A is nothing but writing the number as it is, 1231 without any decimal. B is writing the numbers which are non-recurring. Suppose if I have the number as 1.1231 as recurring, okay. In this case, I'll be writing the B as 1, okay. Or whichever is not recurring, I will have to take that alone, divided by 10 to the power of, how many digits are recurring? 3. So 10 to the power of 3. And in the next number, how many are there after the decimal? Nothing. So put 0, 10 to the power of 0. So 1231 minus 1 is 1230 divided by 1000 minus 10 to the power of 0 is 1. So 999. Either you can stop here or you can get the simplest form after this. This is how you can use the formula and do it. Okay. So now comes your problem. The first problem is all about find any three rational numbers between 5 by 8 and 7 by 12. The problem number 2 is express 12.05 as a rational number. Try these two problems and post your answers. I will be waiting for your answers. Keep doing math one at a time. Okay. See you all in the next video with the answers of these two problems. Thank you.